You've got two situations. You can get a boy or a girl, you can get a head or a tail, you can get a red light, a green light, you can go through a several, you can get a 6 or not a 6. Why don't we start first of all, if I had X for a dice, normal die, let's say for a die, normal die, you can get 1, 2, 3, 4, 5 and 6. Yeah? What can we do? We can get the probability of each of those as, let's write it properly, of X being X, a distribution we're talking about is called X, could call it Y, could call it Z, could call it K, could call it W. Most people don't go to Z though. So you've got the 6, the 6, the 6. We got that. What if I turn that into only two possibilities? Ready? P is the probability of success, which is the probability I'm going to make. I could call it a 1 or a 5 or anything I wanted. Let's just go for 6, most common. Probably getting the 6. So by the way, what's Q then? If that's P, what's Q?
Failure?
Not 6. So of course that's a probability of a 1/6, and Q is the probability of, I can go that way and go not 6. Of course that's 5, 6, and remember the two of them will add up to 1. So there it is with the 6 possibilities. We're going to turn into 2 possibilities now. This is the weird one. This is the one that doesn't make sense to most people's brains. We call them 0 and 1. 2 possibilities. This is failure, and this is success. Probability of X getting X is, what's the chance of success if we define over here the same definition we've got there? What's the probability of getting a failure? In other words, not rolling a 6. 5 out of 6. What's the probability of a success? 1 out of 6. So what am I talking about for this question? P is the probability of getting a 6. So what's Q? Not 6. There's our whole table. We've turned all of that table into just that situation. Now we can calculate the usual things, EX, VARX, standard deviation of X. So let's do it. See if you can switch your brain on. Well, how do we get EX? It's the sum of, I prefer to write PX. So Ewan, how do I write that? Oh, by the way, we've just got one dice. I've thrown the dice in the air and I get the land. I'm saying what's the probability of getting a 6? And that's a Bernoulli. What if I do it again? That's still a Bernoulli. What if I do it again? It's still a Bernoulli. If I keep repeating it, or I do more than one, what's it become? So a binomial is just a repeat of Bernoullis. That's all it is. So why bother with Bernoulli? People do. So here we go. So that's going to be a naught. I was going to say Ewan. So what's probability first? Doesn't matter which way I write it, does it? That's a 5, 6 times naught plus A, 1, 6 by. So that's 1, 6, which happens to be P. So the average, the mean, oh my goodness. The average or the mean, which we call the expected value. What do you expect to get when you throw a dice once and you're looking for the probability of getting a 6? Probably getting a 6 is 1/6. So the mean is just P. So you expect it to be that. So I could do another example and say, what if I had this? Let's make P a new one. P is the probability of getting a red flower. And you read on the packet, and I'm back to my red flowers again. You read on the packet that about a third of them have red flowers. So what's Q? The probability of not red. So what's the chance of it not being red? 2/3. 2/3. So what's my 2 situations? Failure, success. What's the chance of failure? Not getting a red. By the way, does this a failure? They don't get a red. It's just a situation they call failure. It's not what we're looking at. We're looking at red flowers. So there's a 2/3 chance of failure, a 1/3 chance of success. We talk about that's X, and that's probably of X being X. Could you write the table and do all the usual stuff? We've got that there. What's EX for this question? 1/3. So you can just look at it and go, it's 1/3. So by the way, that by that plus that by that is just a third. So EX is just P for what? Bernoulli distribution. Now, how do we get VAR? The VAR of x. You got that thing? Got the p again still? And we got x minus x bar squared. How complicated is it? Not. Maybe annoying because of the fractions involved. So, the probability times the deviation squared, remember they're just the d squared. So what have we got? The probability is 5, 6 times by, bother to do the whole thing, 0 minus the average. What was the average?
1/6.
1/6. And square it. Then we get the probability again, which is 5, 6, so we 1/6. What do I do now? How far is 1 from the average? 1 minus the average is that. What's that called? Variance. Of course you can calculate it. When I get the square root of it, it is the
Standard deviation.
so almost it's like a nonsense simplified case of doing all that. I could have said do EX, that by that, that by that, that by that, add them up. Could have said do all of that stuff here for that, and then turn it back into such a simple case that people's brain mucks up. Okay? So what's this going to be? I need to do it. So that's 5, 6 times by what?
1/36.
Yeah, let's leave all the sixes just for a moment. So that's a 1/6 by 1/6, isn't it? Don't have to write the two negatives. What's this one? 1/6 times by 5, 6 times 5, 6. And of course you can muck around and calculate all that and figure out what it is. So what is it? 5 on 2, 16. You don't know 6 sixes, do you? And that one is 25 on 2, 16. And you get 30 on 2, 16, which is called the variance. Does it mean anything to your brain? No. Now if I said, right, there's a standard deviation of x. So what's the standard deviation? How do you get the square root of 30 on 2, 16? Find out what it is. That's the standard deviation. Yeah. So go back to what it is. The failure is 0. The success is 1. When I look at that number, that is the average, which it makes common sense. Now, here's the formula for the variance of x. Not going to go through it at length now, but just tell you what it is. It's just PQ. Maybe later on I'll go through and show you why it's PQ. So what's the standard deviation of x when it's a Bernoulli? Square root of PQ. So by the way, we can calculate that and see if they're the same thing. Now hopefully I haven't made a mistake. What if I made one slip there somewhere and none of you picked it up? You're thinking, some of you are thinking hard. So the rule is the variance of x is p times q. So what do we have for p? 1/6. What do we have for not p? 5/6. And we've got 5 on 36. Let's compare it. That's what we're saying, that's the variance by the shortcut. Problems accept in your mind. I'll prove it to you algebraically in a minute if you want me to prove it to you algebraically.
It's the same thing.
Might do. And hopefully 6 into that goes 5 and 6 into that goes 36. And there it is doing it as a sum of the probability by the deviation squared. So why would anyone do that when you can just go PQ, which is rather interesting. And your brain doesn't necessarily understand why it's PQ, but I can prove that. We'll go through it now. You okay? So Bernoulli just has two situations. And then it says like, hello, for a Bernoulli. A lot of people just put Bern, but put a Bernoulli. X equals P. VAR x is PQ. And standard deviation of x is root PQ. Now I am going to go a step further and just throw these at you for now, not prove them to you. So for a binomial, it is more complicated. It's been more complicated by how much? N. So if there's 3 of them, it'd be 3p. If it was 5 of them, it'd be 5p. If it was 10 of them, it'd be 10p. So it's a big mental leap. The average of those is NP. We can go through those in a minute. The variance will be NPQ. And the standard deviation is square root of NPQ.
What is n?
The number of trials, for example, you pick 5 seeds, you put 5 seeds in. So anyway, by the way, how else could I write this formula here? There's N, there's P. What's the relationship between P and Q?
1 take P.
Got it. If P is 1/6 and Q is 5/6, Q is 1 take the 1/6, which is 1 take P. So some people like to have less variables written down, they write it that way. So if you look at your waste formula sheet, it's not written that way, it's written this one, NP and 1 minus P. What does my brain see? NPQ.